again, this is where we stopped last time, and I mentioned that this is the last thing in 2.1 that they want you or they ask you to complete in the way that your goal for the last item is how can you translate from English statement to the algebraic expression. So this is what you guys need to know in terms that, again, this word, this item here, this word will associate with addition, and so on so forth. I want to point out this two items. This is the two main items that you want to remember, and I will mention it more when we get to the example. But this two items, subtract something from something and less than, this is the two items that is a little bit tricky in terms of subtraction. But everything else, again, product, time, multiply, twice, triple, or off, those are meaning multiplication. And again, most of the time you will see quotient and ratio divided or divided by. Those are division. And for now, we won't see the equal sign yet. We will see that in 2.4 or 2.5. But let's take a look at what is in store for us in 2.1. The last example we have is they will give you something in this nature, which is they will say write each phase or each expression statement into algebraic expression. Simplify if possible. So looking at this thing here, I believe in your homework, they tell you to use X as the unknown. In class, I say you can use any variable you like. You can use A, N, Y, Z, whatever you like. But again, I believe on your homework, they want you to use X. So let's take a look at A. This is what they ask you is twice a number plus 10, which is, again, twice a number is easy enough in terms of twice meaning double, right? Twice meaning 2, which is twice a number basically tell you that 2 times a number, right? Twice a number. We don't know what the number, that's why it's my X. And straightforward plus 10, which is, again, just plus 10. So in the sense that this is how you were to write your expression. Agree? So again, to go, to have this in mind, or you can print this slide out and then to look at this item to see which terminology refer to your operation in terms of that, right? So twice the number meaning 2x, 2 times the unknown, plus 10, which is plus 10. The B, they ask you the sum of 7 times a number and 3, which is, we know the sum meaning the addition, right? The addition of what? The addition, right? The sum tell us that the addition of 7 times a number, which is 7 times a number, which is, we don't know the number, that's why it's our X. And again, between 7 times a number and 3, which is the addition between 7x and 3. We cannot simplify because they are unlike term, right? So this is your unlike term, which is 7x plus 3. And hopefully you guys see the difference between B versus C. And I purposely give you that item in terms of 7 times the sum of a number and 3. So looking at this thing here, what is the main difference between this item? One of them is the sum, which is the main objective or the main connector or operation is addition. But this on the bottom, C, multiplication, which is 7 times the sum, literally, this is what we have is 7 times the addition. But the addition of what? Meaning, in the sense, this is what I tell my student is, if you can see, or if you know, there is a small comma, 7 times comma, the sum, which is, again, I told my student, oh, this is what you want to see is if we have a double operation, if we have double operation next to each other, there is a small pause. And if there's a small pause, meaning there is a parenthesis, which is, again, 7 times the sum. Literally, this is what we have is 7 multiplied to the addition. But we cannot just multiply to addition, the addition of what? The addition of a number and 3, which is, again, we need the parenthesis in terms of this item here, which is 7 times open parenthesis x plus 3, okay? 7 times the sum, this is literally 7 times the sum. But again, we need to know the item, which is looking at this thing here. All they ask you to do is we need to simplify, which is we distributive them in, which is 7x. We distributive them in, which is 21, which is, again, the simplification of this item is 7x plus 21. Clearly, you can see that it's different from B. In terms of B, we have 7x plus 3. This one here, because of the parenthesis, we need to distributive. And when you distributive, you have 7x plus 21. Same idea go with D. We see if you read this, we have 3 times past the difference, which is literally, again, same idea, 3 times the difference, which is 3 multiplied to the subtraction. But the subtraction of what? The subtraction, which is we need a parenthesis. Okay, so most of the time you will see, all the time I tell my student is, if you see the double operation next to each other, then you need to separate the operation by the parenthesis. So most of the time when you see time the sum, time the difference, unless it's time the number, like B is time the number, straightforward, you multiply to the number. But if you have time the sum, time the difference, time the whatever the operation, if you have double operation, you need to have that parenthesis. And again, similarly, look at this thing here, we distributive to give us 3x, and we distributive to give us 15, which is, in this case, we have 3x times minus 15. And E, hopefully you guys see that it's straightforward. The different, which is different meaning subtraction. Subtraction of what? Subtraction of 3 times a number and 5, which is, again, 3 times a number, which is 3x, and 5, which is, excuse me, 3x minus 5, right? So it's just straightforward. They don't have a double operation together, so they don't have the double operation. That's why we do not need the parenthesis. Okay. And lastly, hopefully this is what you guys will see. Lastly, one thing is you guys will see the word form. And like I mentioned to you guys earlier, the word form and the word then. A small note that you need to put this in is anything follow the word form have to go in front of the operation. Okay, so if you look at this thing here, anything follow the word form have to go in front of the operation, meaning look at this thing here, we know that it's a subtraction. The operation tell you to subtract 21 from 5x, which is, we know the operation is subtraction, but anything after the word form have to go in front of the operation, and anything else, meaning in terms of this thing here, they have that reverse item. So we take 21 away from 5x, meaning the 5x is the dominant one. Okay, so we're not taking 5x away from 21, right? So in a sense, anything after the word form have to go in front of your operation. Same thing with the word less than. If we have 5x is less than 21, then again it's going to be 5x minus 21. So the word less than and or the word than and the word form, they have that reverse, which is whatever came after that two word, the word form or the word then, they have to go in front of your operation. Okay, so again, it's just a small item that you need to know or understand the English that you can translate to algebra. And one thing about math is, the math sometimes is very easy, but it's the English, the word problem that make you guys, kind of hesitant and get intimidated, right? But again, look at this thing here. Question with this item that we have in terms of this seven question or 7 expression that we need to translate. Any particular question here? If you don't have question, ladies and gentlemen, that is the end. That is the end of 2.1. Let's take a look at 2.2 and 2.3, which is reminder 2.1 2.1 is just basically combine like term, ask you to combine like term, and then use the distribution or distributive property to simplify or to get rid of the parenthesis, and at the end, how do you translate from English to algebraic? Okay, so in 2.2 and 2.3, I put them together because the two multiple or the two items are very similar. 2.3 is just a addition of 2.2. Okay, so first of all, one thing I want to point out that this is your linear equation, and as you can see in 2.2 and 2.3, we are start to deal with equation. And the difference between equation versus expression is expression, they don't have an equal sign. The equation, they do have an equal sign, and if there's an equal sign, basically your goal is you need to solve for x. Okay, so looking at this thing here, this is your linear equation, which is one variable, which is just an x, and this is your easiest problem, ax plus b equal to c. And I will keep on mentioning that this is the easiest item you have, ax plus b equal to c, in terms that to solve this thing here, all we need to do is subtract b over and divide by a. What does that mean? Which is, again, in 2.2, they have this additional or adding property of equality, which is basically tell you that if we have a is equal to b, and if we added c to one side, we have to add c to the other side. And again, basically, you have to be fair in the sense of this item here. So same thing with multiplication. So basically, whatever you do it on one side, you have to be fair and do it to the other side. So that's what our goal is here, is to solve for x. And our goal to solve for x is basically whatever we have on one side, we need to do it on the other side too. Okay. So looking at this item, let's take a look at 2.2. And 2.2, as you can see, are A, B, and C, and D. A, B, C, and D is 2.2 material, which is they have only one operation and we're done. So again, look at this item here. This is what they ask you. If you look at A, all they ask you is pick me a number. Whatever number you can come up with, pick me a number that when I plug it in there, I take away 13, and the result is equal to 16, right? So if you look at this thing here, and again, you can guess, you can say, okay, 29, right? 29 minus 13 will give me 16. We can sit there and guess, but looking at this thing here, to go back to our property, basically to solve for x, your goal to solve for x is to isolate x. Which is to isolate x, we know that we need to remove, or we need to take this item and move to the other side. And again, to do this thing here, many of you or all of you already know that to solve, we need to do the opposite operation. And if we do it on one side, we have to be fair. Like other one, we have to be fair. If we do on one side, we need to do on the other side, which is in this case, negative 13 and a positive 13, they cancel out, right? Negative 13 and positive 13, they cancel out, which left us with just x on one side. Give us x on one side, and again, 16 plus 13 to give us 29. But you already know that. We know that 29 minus the 13 will give you 16, right? And again, similarly for B, if we have x divided by 6, and if we have x divided by 6, which is, again, how do I get rid of division? Well, to get rid of division, I need to multiply. So look at this thing here. All we need to do is take the denominator and multiply the other side. Or to be safe, this is what we have, is we multiply 6 on one side. And if we multiply 6 on one side, we need to multiply 6 to a other side, which is, again, this 6 and this 6, they cancel out, which give me negative 8 times 6, which is negative 8 times 6 to give me negative 48, right? So again, looking at this item here, we haven't done anything new, and hopefully this is what you guys remember. In terms of solving for something, we need to do the opposite operation. And again, if it's addition, we need to subtract. If it's subtraction, we need to add, right? So similarly, in terms of C, looking at this item here, we know that we need to get rid of the 17. And the 17 on the left is positive. And if it's positive on the left, we need to move it to the right. And again, if it's positive on the left, to move it to the right, I need to subtract, which is again, 17, take away 17, they become 0, or your y is by itself. And again, 23, take away 17, this will give you 6. So look at this item here, question with the first 3 problems. Question with the first 3 problem here. And again, the 4 problems should not be challenging because again, if we multiply. So the first thing you want to ask yourself is, again, what kind of operation you have, right? In terms of this thing here, we have -7 multiplied to a. And if it's multiplication, to get rid of multiplication, we need to divide. Right? So we always do the opposite operation, which is we want to get rid of this -7. And to get rid of this -7, we need to divide by -7. And again, if I divide on one side, I need to divide on the other side, which is -7. -7 become 1, which is my a is by itself. Negative going to negative become a positive, which is in this case, a is equal to +5. Sorry about that. A is equal to +5, not a -5. Okay, so looking at this item here, question with this thing here. Again, this is +5.
And it's +5 because 2 negatives equals a positive, correct?
Yes.
Okay.
So question with the first 4, which is the first 4, hopefully is, you can see that it's easy in the way that it's only one step and done. Your goal is you want to get x by itself, a, x, a, y, z, whatever the letter is, you want to get that by itself. And to get it by itself, you have to move across the equal sign. And to move across the equal sign, you need to do the opposite operation. Okay.
Explain B one more time.
B?
Yes.
Again, looking at this thing here, we want to get rid of the 6. And because the 6 is on the denominator, or in terms of x is divided by 6, and to get rid of the division, we need to multiply, which is again, if you multiply, if you go back, if I go back, which is, again, this is what we want. We want to move the 6 to the other side, which is, like I mentioned, if I want to move the 6 to the other side, all I need to do is multiply, right? I just multiply the top, the numerator. Basically, it's 6/1, as you will see in a little bit, the example F. But again, it's basically 6/1, 6/1. But looking at this thing here, the 6 on top and 6 on bottom, they cancel each other out, which is 1. That's why I have just x by itself. And if I multiply on one side, I need to multiply on the other side, which is -8 times 6 to give me -48, right? So again, the x is, only x is by itself because the 6 on top and the 6 on bottom is equal to one whole number, or just a number 1, right? Is that clear?
Yeah. Yeah, perfect. I just confused myself on something else, that's all.
Okay. Again, just ask yourself, look at your problem and identify what kind of operation you have. And if you can identify what operation you have, then all you need to do is tell yourself, well, if I have that operation, I need to do the opposite to get to the other side, okay? And let's take a look at E, right? E is a little bit different in the sense that E, now we not have just one operation, but now we have 2 operations in here. We know that there's a subtraction and there's a multiplication. Our goal is we want to get rid of that 3 and we want to get rid of that 2, because to solve, we need to get x by itself. And one thing I tell you guys is this is solving is like a backward of the OR operation. Remember, you know, if you do your OR operation, you do your exponent, you know, parenthesis, exponent, multiplication, division, addition, and subtraction last. To solve, we basically go from bottom up. One thing is you want to get rid of addition and subtraction first, and then multiplication or division later. So looking at this thing here, after that, as you can see, the first thing you want to get rid is you want to get rid of the -2 or the -2. And if it's -2 on this side, to get rid of this, I need to add 2. Again, if I add 2 on one side, I need to add 2 on the other side, which is in this case, my new problem after I get rid of this 2, my new problem is 3x equal to 27. -2, +2, they equal to 0. I don't need to put a 0. And again, 25 plus 2, you all know 27. And look at this thing here, we're back to number D, which is how do I get rid of multiplication? How do I get rid of this 3? To get rid of this 3, I need to divide, which is if I divide one side, I need to divide on the other side, which is in this case 27 divided by 3 to give me 9. Okay, so again, your goal is you want to get rid of your addition or subtraction first, and then multiplication or division last. Okay, so looking at this thing here, similarly, let's take a look at F, and then I would see if you guys have question. Similarly, hopefully you guys see that we have a 1 and the 8. That's the two numbers we want to get rid of. And because of the addition, I want to get rid of addition first. To get rid of addition, I need to subtract. And ladies and gentlemen, reminder, looking at this thing here, even though we say subtract, but if they have the same sign, right? If they have the same sign, which is in this case, they have the same sign, we need to add and keep the sign, right? We have a -5 and a -1, which is again, in term, -5, -1, you owe me $5, you owe me another $1. In total, you owe me $6, right? Which is -6. So reminder, even though I say we subtract, you still have to use that rule of sign. Same side we add and kept the sign. Opposite side we subtract and kept the sign of the larger number. Okay, and look at this thing here. Once we have this, we want to get rid of the 8. And like I mentioned, when you get rid of the 8, we need to multiply. Again, same thing would be, I did not put a 1 here because again, basically you multiply by 8 over 1. I put the, if you look at B, I put the 6 up here, but again, anything over 1 is just itself, right? So basically this is what you do, you multiply by 8 over 1, but anything over 1 is just itself, so I just put an 8 here, which is the same idea. It's the same answer. Looking at this thing here, which is again, the 8 and 8 cancel out, which is in this case, -6 times 8 is equal to -48, which is again, the same answer as in B. It's just the 8 and the -6 swap. So looking at this thing here, question with this first 6 problem, in the sense of, you know, we start with 1 operation and done, and then we have end up with 2 operation and done. Again, your ultimate goal is you want to get X, Y, or whatever that letter by itself. And to get it by itself, you need to do the opposite operation. Okay. And again, let's keep it consistent. Put the X to the left, and then move everything to the right. And when I say move, meaning you do the opposite operation. So question here in terms of this 6th problem. So if you don't have a question, let's increase the difficulty a little bit, right? So they will add on, which is 2.3, they will add on and they will give you something in this nature. And hopefully you guys see that looking at this thing here, again, looking at this item, we have A as in this item here, which is again 5x plus 11 minus 2x equal to 22, right? Your goal is the same as before, have not changed. Your goal is you want to get x by itself. So I want to point out, first of all, this problem is different from the previous one in the way that you have your x on the same side. And reminder, ladies and gentlemen, if you have x on the same side, which is, again, your goal is to combine like tone, okay? Remember, I told you guys, you say, wait a minute, back then we do the opposite operation. Again, the only time you do the opposite operation is if you move across the equal sign. If they are on the same side, which is, as you will see, when I have a yellow color coded, my yellow color code is they on the same side. And if they're on the same side, all you do is you combine like term. In this case, you have 5x minus 2x, which is 5 minus 2, you still have 3x, which is, everybody see that after you've done the first step, you want to combine your like term, which is after you've done the first step. Now we get back to this easy, hopefully easy problem, which is, again, ax plus b equal to c. This is your ultimate goal. No matter how big the problem is, your ultimate goal is to get to something like this, something times x plus or minus something equal to a number. Because look at this thing here, all we need to do is we need to get rid of the 11. And to get rid of the 11, or to move the 11 to the other side, because there's nothing to combine here, I need to get rid of this. And to move this to the other side, I need to do the opposite operation, which is, again, if it's add 11, I need to subtract. And even though I say we subtract, ladies and gentlemen, negative 22 and negative 11, they are the same sign. I need to add and keep the sign. Okay, you have to remember that rule of sign. Same sign, I need to add and keep the sign. Opposite sign, I need to subtract and keep the sign of the larger number. Okay, and again, once you get rid of the addition by subtract, we need to get rid of the 3, which is the multiplication. And to get rid of multiplication, I need to divide. And to divide this thing here, which is, again, 3 going to 3 is 1 time, that's my x. 3 going to negative 33 will give me a negative 11. So looking at this thing here, question with this problem, question with this A. Again, make sure you identify, the 20 is not in yellow, it's only the 7x and the x. Make sure that you identify that this thing here, this item that we have, is like tone. And one thing is, if you don't move across your equal sign, you do not do any opposite operation. The other thing I want to point out is make sure that you guys remember that if there is no number in front of the x, is imaginary 1, right? There is 1x, okay? So if there's no number in front of x, there's a 1 in front there, which is, in this case, you have 7x plus 1 more x, and 7x plus 1 more x. Everybody see that we have 8x in total, minus 20 equal to 36. And like I mentioned, this is your ultimate goal, ladies and gentlemen. Your ultimate goal is, how can you, whatever the problem is, how can I make it in a sense that we have something times x or something divide x, added or subtract to a number equal to a number? Because once you get to this form, all you need to do is get rid of the 20. And to get rid of the 20, we need to add 20, because the 20 is negative. We need to add, which is, if I add on one side, I need to add on the other side, which is, in this case, I have 36 plus 20 to give me 56. And I need to divide by 8, which is, to divide by 8, this is what I have. And again, 8 going to 56 will give me x equal to 7. 8 and 8 is equal to x. And again, 8 going to 56, or 56 divided by 8 will give me 7. So first of all, question with A or B here? Any questions so far? And let's take a look at C, which is, again, looking at this item here, as you can see, it's look kind of monster, right? It look like it's big. But no matter how big the problem is, ask yourself this question here: how can I make it smaller? And to make it smaller, the first thing I want to do is there any like term? Is there any like term on one side of the equation, which is, do you agree that this is my like term, my x, 6x, negative 6x, and a 2x? And if I do that, which is 2, take away 6 to give me a negative 4. And do you agree that this is also my like term, which is 28 take away 8, which is 28 take away 8, I have 20. Which is, everybody see that after you identify your like term, my like term is this item, I have negative 4, and 28 take away 8, that's my other item, which is, again, if they on the same side, you do not do any opposite operation. If they on the same side, whatever operation they have, that's what you perform. Now, everybody see that we have some number times x plus a number equal to another number, which is, looking at this thing here, we know that we need to get rid of the addition first, which is, to get rid of the addition, we need to subtract, which is 12 take away 12, they cancel out. 20 minus 12, easy enough. 20 minus 12 is 8. And again, look at this thing here. How do I get rid of the negative 4 in front of my x? Make sure, ladies and gentlemen, make sure that this operation that you have right here, because of the 4 is in front of the x, meaning 4 times x. To get rid of a multiplication, you cannot add. To get rid of multiplication, you need to divide. Okay, a lot of, I cannot say a lot, but just a few of my students, when they saw negative 4x, they say, oh, negative 4, I can add. Again, because it's negative 4x, meaning negative 4 times x. And if it's times x, to get rid of that negative 4, you need to divide it by negative 4. You cannot add to get rid of multiplication, okay? You only add if there's a subtraction. This thing here is a negative 4. There's no number in front of the 4. So again, that number is a negative 4. And to get rid of that negative 4, we divide, which is 8 divided by negative 4 to give me a negative 2, okay? So again, looking at this thing here, first of all, question with the first 3 problem here. And if you don't have a question, what is the difference between D versus the previous 3? Well, in D, you can see that there is a parenthesis. And if there's a parenthesis, just like always, if there's a parenthesis, we need to distributive whatever my number in my parenthesis to get rid of that, right? Because 4x minus 1, there's nothing I can do because 4x and 1, they are unlike terms. So the first thing I want to do is, again, take the 3, multiply to this number, take the 3, multiply to this number, which is, again, 3 times 4 will give me 12x. 3 times negative 1 will give me negative 3. There is no more parenthesis. And again, everybody see that we, after your distributive, this is my new problem, or this is the problem I have, is 12x minus 3 equal to negative 27. And that is an easy problem, ladies and gentlemen. Why is easy? Because looking at this thing here, I have something times x minus a number equal to another number, which is, I know to get rid of this thing here, I need to get rid of subtraction before division or multiplication. And to get rid of subtraction, I need to add, which is, again, negative 3 plus 3, that becomes 0. Negative 27 plus 3, that will give me negative 24, which is, again, my problem, my new problem after this step. I have 12x equal to negative 24. And to get rid of the negative, or not negative, to get rid of the 12, I need to divide. And if I divide negative 24 divided by 12, do you agree that x is equal to the same answer as C, which is x is equal to negative 2? Okay, so to get rid of the parenthesis, your goal to get rid of parentheses, we need to distributive them in.